Okay, we got the package from JLCPCB. This is the first time I had the assembly service purchased on top of these two boards being made. We have a rigid board and a flex board for the FlexGrid version 4. So here are the 10 partially assembled boards. I had just mostly the pieces that were tedious, like the resistors, capacitors, and some of the basic ICs, specifically the gyroscope, which is very hard to solder. It's for me, so that was probably worth it in and of itself. So I'm going to assemble two boards today, and we're going to take a look to see what version 4 can do for us. So here are the Flex PCBs, a little bit different design. It mates on the left side. We can see those surface pads that are the main sensors. And then I have the grid pattern on the back. So I'm going to line these up, show you the version 3 versus version 4. On the bottom left is the version 3. It's horizontal, as you can see. And version 4 is more in line when this is going to be going on your arm. And so I think overall version 4 has a lot of upgrades that we're going to benefit from. So we'll take that away and just look at version 4. We still have to populate some of the rest of the components, and that should be easy. We got the ESP32, the multiplexer, the ZIF connector, and finally the buttons on the top right. So this should be relatively painless, and let's go ahead and inspect the board. So I do have that U5, which is the ESD protection, that we're going to have to flip around later, and everything else looks good. D5, which is the RGB LED, they didn't have in stock. So I'm going to go ahead and start and apply the solder paste. So I'm putting a little bit too much solder paste. We're going to come back and clean these up, but I just need to get them placed for us. And of course, since these are already populated, I can't use a stencil to actually squeegee on the solder paste, but we're going to make do with what we have. Let's place that ZIF connector. It's kind of scary looking because the pin pitch is so small, but it is not that scary as long as you have time and patience and solder a copper wick. That's and flux and copper wick is your best friend when you're doing anything that's small pitch like this. Okay, so we have the components placed. We have the components placed, and we're going to use the heat gun to just melt the solder paste and get these adhered to the board. This is a $40 soldering iron, or this is a $40 heat gun from Amazon. Works well. We're going to have to use this on the back as well. And like I said, we're going to clean this up in here. Let's take a look at our damage. It's not too horrible. We have some pins to clean up, so I'm applying the copper wick that already has flux on it. You can see the flux kind of melting there, or just becoming less viscous. And running under the board. Made quick work of that ZIF connector. And this is something that you'll want to do if you're ever soldering these small components. It's really difficult to get the right amount of solder paste on. And these mechanical connectors for the USB are pretty important because we're going to be plugging and unplugging this thing in, and these 4 little pads here are going to help it to hopefully not rip up the traces on the board. Now, that would be bad for us. And clean up the second ZIF connector. Do a little inspection. And this looks decent. Bridged a lot there. And going ahead and getting those mechanical connections made. Make sure not to accidentally do what I did and put solder on the inside of the USB module. Okay, now for the back side, we're going to put the ESP32. I'm just like tapping the solder paste onto the surface components, the surface pads. This is very difficult, especially the ESP32 and the under those 9 pins, those 9 surface pads on the bottom. Those are hard to get right. So you don't want to apply too much because you can actually have some bridging underneath. So it's kind of dangerous. So I try to err on the side of too little, and I'm going to go back and clean those up. We get those 2 multiplexers placed on there. And then good old heat gun time again. And we'll get everything soldered decently on the board. This stage is a little It's a little nice since we have all those resistors already placed. The rest of the components on the back are just for haptic feedback, and we're not going to be populating that on this board. Also, we don't have the SD card reader. I haven't purchased that component yet, but we'll be adding that in a future video. You can see me taking my time with this. It's probably the most important part, to make sure all these pins are connected. As we can see, there's some gaps between some of them. That's why I go ahead and try to solder each of these pins by hand, just to make sure that they're fully mated to the custom PCB. There are some cold solder joints here. I do apologize. This is a prototype board. This is not going to go out to anyone. This is just my first 2 test ones that I'm going to use. But if you're at home and this is what your solder job looks like, it will still work. But do not be taking soldering tips from me at this moment. Yep, we see there was a little bit of gaps there again. This verifies why I'm having to clean up these pads. And looks good. Now the multiplexer and the other board. I'm just going to quickly run through this, not show the whole video. But applying solder paste is a little bit easier. I would encourage this as opposed to that giant solder. Now for the buttons. We're only going to populate 3 buttons. We just need the reset, the boot, and the power. The menu and select are, when the device is actually up and running. You'll probably want to populate these as well. But I think these buttons are pretty expensive. They're like, I don't know, 75 cents each. So I only put 3 on when I'm testing these boards, and I can always solder more on those other 2 once I'm done. It is kind of funny just like not populating an entire board. It's just rather fascinating. These are 4-layer PCBs, and so pretty fun. Oh, and then I forgot that I messed up the ESD protection. So for electrostatic, I actually messed up the polarity of the ground and V-bus. So I had to rotate these 180 degrees, but luckily they work rotated 180 degrees. That's not always the case. Did a pretty bad job soldering it, but it wasn't being recognized by my computer. I was kind of bummed by this. Anytime you get a new board that doesn't work, you can't flash it. It kind of one of those gut punches. But we got it working, as messy as it is, that we can now see if the Flex PCB can mate with that ZIF connector, and just getting it slotted in, and it's almost a perfect fit. So this is great. This is the best case scenario where we actually have everything's mated properly. It just looks cool. So exciting stuff. So we have a board fully assembled, and it functions. I actually flashed it off screen, but I went ahead and made my own cloth housing for it off camera. And we're just going to take some of the Velostat and just cut out the custom piece to go on top of the board. This is going to just be taped on. The Velostat itself is pretty well. This is kind of disposable anyways. Velostat will probably have to be replaced if this is actually used. That crease won't really bother us too much. The sensors work pretty darn well with pressure. And so even with that crease, it's not an issue. And I'm sliding it into the housing, putting the rigid PCB in a pocket that I made, mating the connectors, and here we go. We have a fully assembled version 4 FlexGrid from OpenMuscle. Very exciting. I'm going to add some tape to the back. I need to get some material and actually just have this be a part of the cloth housing. But because there's adhesive on the backside, it will ruin my sewing needle, so I'm not going to sew it on. So there we go. Fully designed FlexGrid version 4. Now we can see version 3 above it. It had some elastic and an extra strap. We're going to have to engineer this cloth housing better. Have the elastic like the other one, just so it puts on the arm better. But for now, we at least have a rough draft to begin our testing. Very exciting. So thank you for watching. Please follow, like, and subscribe if you like this video. And as always, let's see if we can make a positive difference in this world. Till next time.